Good morning, everybody. I know it's early on, right? So some people are still in wake-up mode, but it's great that we have already a couple of people around here. So today, I'm talking about NEMO Explorer XR. I think that 1 or 2 years ago, I talked already a little bit about the NEMO project before, so some of you might have seen some of the slides before. But so I'm amazed to talk in this session today because it's on visualization facilities, and I will talk about a new facility we have at the Royal College of Art. It just started a few months ago, and we were waiting for a very long time that this is kicking off. So, and I think this is the first talk which is actually addressing the visualization facility at our college until this point in time. So let's dive into it. So first of all, I say a few words about the NEMO project. So NEMO project is the new economic models for the ocean project, which started a couple of years ago at the Royal College of Art. So the basic idea is to use design-related methodologies to address problems all around the ocean, which can be complex problems or very specific problems. And as I think nowadays everybody is familiar with these SDGs, so the Sustainable Development Goals. So here are a few of them which we are trying to cover in our project. So, and it's quite diverse, it's a big topic, and we became part of the Ocean Decade, so the UNESCO Ocean Decade a few months ago from the RCA, and yeah, since then we are basically part of this conglomerate of a couple of different initiatives around the globe tackling ocean-related issues. So, and for example, one of our collaboration partners is the National Oceanographic Centre in UK. So I will not spend so much time to talk about the NEMO project today. I will focus on one specific journey which we did right after the pandemic, which was on the St. Helena ship. And the setup on the St. Helena ship was that we had 4 different cameras, and on each side of the ship there were 2 cameras, but this was actually done before I came into the game. This means this was not a stereoscopic camera, so the approach they basically had is they had 1 zoom-in camera and 1 wide-angle camera, which turned out did not make much sense because basically everything which was recorded with the zoom was not really useful. So in the end, we just used the wide-angle camera. So it's kind of a missed chance. But again, so I came into the project when they said, okay, here is the material, what can we do with it? And you can see it was installed on the monkey island of the ship on both sides. So starboard and on the port side of the ship. So, and here you can see, so my colleague Ashley, who is installing the camera here on the ship. So it was a very hands-on design engineering project, which is actually also expanding now. So so last year there was another journey happening, and this year there will be the next coming up. And interestingly, so that's something I mentioned already. So we are thinking about this time, of course, to film this in stereo. So, but this was the setup. So, and in the ship, we had here this the setup of the different recording devices. So that were a number of hard disks, which were directly hardwired to the cameras, and in this way we basically recorded the video, and we recorded terabytes of data, which were afterwards then basically recorded to hard disk, and then we distributed them on our college later on. But so the main problem is, if anybody here ever tried to record something on the ocean so far? No, not really, right? So the main problem is you have no internet, or if you have internet, it's super, super expensive, right? Because it's in international waters. So obviously, so Andrew has a lot of experience in recording underwater, right? So initially when they started this project, they were thinking about, can we actually stream it via internet? But it's basically, you cannot pay for it. Afterwards, the whole college is bankrupt, especially the route which we have taken. It's just not possible. And that was the setup. So on one hand, we had the St. Helena ship, where we installed the cameras on. Then we had the local NVR server. Then later on, afterwards, I basically brought it on the RCA server, so which is somewhere in the basement as the RCA in the South Kensington campus. And then I connected this to a cloud server, which is running Cesium. So I will also show you a little bit more about what the Cesium framework looks like. But that was the technical setup so far. And Cesium itself, it's an alternative for Google Maps, which is directly connecting to map providers. So for example, Bing, Cesium, Google, so one of those different setups. So the video data which we have recorded was 4K data. So this is here one example. So you will shortly see the whole journey. So this is when we were leaving Greenland with the ship. This was recorded actually. And the purpose of this journey was in the beginning to track objects. First focus was on garbage, but after some time we found out that based on the methodology which we used, we did not track really much garbage, we did not see much garbage, we saw a lot of birds, and we saw here, for example, fish in the water. So this is here, for example, an Arctic seal. But the problem is, of course, because the camera was mounted on top of the monkey island, you don't see so much of the overall environment. So, and then it's hard to recognize this. And we had actually, at the end of the project, we had one student looking at the data and basically identifying different objects, and then we categorize them into different object categories. If you want to learn more about this, because it's not the main topic of the talk today, and I have to keep it short, feel free to, later in the demo session, I'm happy to talk more about this. So the data visualization, this was something I was working on in the beginning, and this is something I implemented in Cesium. So this is how it looks like. It's a web-based application. So, and what you can actually see there, that's the whole journey, which was taken by the Sardinia, so starting from Greenland. And what you can do with this implementation is you can, so as I said, it's a web-based tool. You can directly click on the corresponding identified objects and then jump into the corresponding video material, into the corresponding point in time. And I basically had to do the calculations like interpolating the GPS data based on that, and then identifying the different objects here. We were using, so that was 2021, 2022. So we used some off-the-shelf AI technology to try to detect objects, but this was not optimized for on the sea. So this means that it was not really working well. We identified only a very limited amount of objects on the ocean. And this is why we, in the end, had to follow the route that somebody else had to do it manually. And in the future, of course, we will improve this approach. But that's basically what we can do with this application. And as I mentioned before, so that's completely web browser based. So what do we want today? What is it what we want to address today? So actually, what we wanted to do now is bring this into our VisLab environment. So we wanted to enable a co-design environment. So I will shortly talk a little bit more about that, about this particular topic. So the idea is to bring in particular groups of experts who can then observe the data and not just looking on a small screen, but basically use then what you just saw in the talk from Andrew, for example, if you have something like the Hive, so you have very large visualization environments, and that's what we wanted to use for our purpose. And the question was, how can we actually do this? So that's the RCA SNAP Lab. So it's basically sponsored by SNAP. And that's a setup, the technical setup. So you see you have one host PC, and each of them is driven by an Intel Xeon processor. You have 128 gigabytes RAM from each of them, and you have in each one NVIDIA RTX 6000. And I just integrated this picture here because I know that most of us want to see something like this. So that's our server room. So here you can see the 6 node computers which are connected to each other. So, and the interesting bit is here, you can probably not see it. Each one is at the moment connected with a wireless adapter to the internet, which means that the bandwidth is very, very low. So the problem is The main computer is connected to the internet, so basically this one here. The host PC is directly connected to the internet, but all the other ones are not, which is a big problem for Cesium, because Cesium has to connect directly to the internet. And again, because the VisLab is brand new, this was not implemented in the beginning. And so we basically had to use this workaround, and you will see in the recorded videos that we had to work around it a bit then. So, and that's the setup in the VisLab. So you have this 5 different projectors, each one 4K resolution. Each one is able to project stereoscopic images. Sorry, I cannot show this here today, but we managed to make it work. Also, if not for this particular project. So they have 21,000 lumen each, and they are Barco projectors. And the interesting thing is that those are basically blended, the 3 which are aiming to the front. And you have at the side some which are basically rotated. You will see this shortly here. So that's the setup at the moment. So on the left and on the right side, you have them basically in horizontal setup, and the other ones are vertically oriented. And of course, you will also see that you have a kind of blend here in between. And that's the software which we are using. So at the moment, the approach which I'm showing here is actually using Vertex. But the final target is to use Unreal Engine in combination with NDisplay. So what we are doing at the moment is, for the video I recorded here, that I use Vertex connected to one additional computer, which is running Unreal, and is streaming then to the front 3 projectors via Vertex, then the Unreal renders. Great, so that's a control room. So you can see here that's our NEMO computer standing here in the front, which is actually equipped with a GeForce, what is it? GeForce, I think 4080 RTX. But it's a GeForce, it's not a Quadro card, not an RTX. It's a GeForce card. So, and this is streaming via Vertex to the front here. And in the back, you can see the VisLab. So, and this here is a first test using Cesium directly from Unreal. It's an image, and you can see here the setup. So at the front, you can see the 3 projectors. Left and right side, you can see the horizontally aligned projectors. And as a disclaimer, so I was not asked in the setup, so this was prepared by other people. I have tried a couple of times to get involved in this, but yeah, it did not happen. So we basically were just presented, that's the setup, work with it. Because obviously it's an interesting setup here at the top right, so that you have here this kind of corner here. So it's kind of arguable if it makes sense. So that's the first video. So that's the idea of how we want to work with the NEMO Explorer. So we have at the front, that's now the Unreal projection, using Cesium in the background. And on the left and on the right side, you can see the videos, which are actually streamed directly from the internet. So, and here you can see it in action. Yeah, so just to give you an idea of the scale, I invested a lot of money to get a very bad actor, but yeah, so you have a idea how, in terms of the size, and it's quite impressive because especially if you bring in, for example, tree visualizations or something like it's really full scale, so it's kind of amazing, and I think that's a big advantage of this large scale Barco projections here. So, and here you can see the journey that's basically starting from Greenland and leaving Greenland. Now the overall journey went from Greenland to Sardinia and then back to UK actually. And you can see here, because it's streamed at the moment via Vertex, you can partly see here that it's not fully synchronized at this point in time. But this is something we will tackle now in the next stages. And you can see another example. That was something which happened to the end of the recording. So actually the projectors were overheating. So at the end of the session, so I had all my recordings already done, but then they started overheating, and I just have this in because it's also changing now to the Unreal screen. So you can just see, so that's actually how it looks like when I stop the application. So that's, if you look it up, so Cesium comes with the Unreal plugin. You can also use it with Unity. and then you can basically combine both worlds. Great, so what are the next steps? Of course, we want to make it run in stereo, right? So that's, of course, super important. And it's just that at the moment, the Cesium implementation, as you can see, has a problem anyway because the internet connection is too slow. So that's something that we need to have a hardwired connection in the end. And that might take a few months until our technical team is solving this because they just did not lie the wires there. Then the problem is it's active stereoscopic recording what we have to do. So these are active glasses which are used in this environment. So this means there will be always some kind of flicker. So that's a big advantage if you have passive stereoscopic visualizations. And the other thing what we want to do is then basically to synchronize the browser implementation with our center Unreal environment. So this means that if we basically navigate here through the environment, like here, if we navigate through this environment, that then basically we can synchronize the left and the right side of our videos here to the environment which we're actually seeing here in the center. Yeah, and in parallel what is happening, so I showed you in the beginning there was this NEMO Explorer, the first version which we are working on for Cesium, for the web, and we are working on the second one, which will also take into account the new data which we are collecting. That's a team behind it, which we are working together. So especially Alyssa is working a lot on the second version of Cesium. So I developed the first one. She's working on the second one. Yeah, I was mostly working on the XR version of that. And my colleagues, Carla, Elise, they're more looking into the co-design elements of it. So Ashley is at the moment leading the project, the NEMO project overall. And here just as a preview, that's something else that's actually running in stereo in the lab. So that's another project I just visualized there that's actually done based on a project which I did some years ago, and I think I also showed here already in the context of Virtual Studio. And this is actually visualized here in Unreal Engine, and the whole visualization was set up in Blender. So I basically set it up in Blender, imported it then into Unreal. And yeah, so you can see, especially it's really interesting if you have this large-scale posters, for example. So it's a really nice way to interact with this large-scale visualizations. Great, thanks a lot, and I'm happy to take questions.